Hello everyone, welcome back to Mindmatrix YouTube channel. I'm Sachin. So today we will be proceeding further with the next topic within our machine learning course. Okay, so the today's topic would be evaluation matrix for classification problem. I hope you have seen the last lecture where we have already discussed evaluation matrix for regression, where we discussed about mean absolute error or mean square error, or mean absolute percentage error, mean percentage error, and what else we had, r squared error. Okay, so I hope you remember that. If you have any kind of doubt, you can comment over there within that video. I'll be answering you that, need not worry about that. So now I'll be proceeding further, okay, with the classification problem based evaluation metrics. So one important request, if you are not following, okay, please do follow from the starting, then only you'll be able to understand properly. Though I have made each of these lectures in such a way that you'll be able to understand, but still, just to understand properly, you should be starting from the first lecture. Apart from that, it's a request, if you are getting benefited, if you are learning, if you are able to enjoy these lecture, kindly do like, share and subscribe the channel, because I can still see people have good average view duration, they are liking the lectures. Okay, there are good number of views I'm getting, but still people are not subscribing. Please do subscribe, guys, if this is benefiting you. Okay, so let's proceed further. So that was the request. I hope you'll do that. Okay, so let's proceed further. So yeah, there is the biggest surprise, which is going to be tomorrow evening at 8:30, which I and Anshul sir would be revealing. So just be prepared for that. As I have mentioned in the last session, that yeah, you might be hoping that what it can be all about, but still, there is much more to it. So I anticipate that you all guys would be there. There is big surprise for you guys. Okay, so see you guys tomorrow with respect to this session. So yeah, a brief intro. So if you have been following me, you know this. It's okay. If you don't know, you can just read through that. I won't be reading it now. So let's just talk about the evaluation metric for classification problem. So I hope if you have seen the last lecture, you have already got to know that why do we need exactly evaluation matrices. Basically, we want to know, like, what is machine learning? Machine learning is simply, you're learning from the data. So whenever there is a thing called learning, whenever it is associated, we always make sure to test the knowledge. Remember, like you as a student in your childhood, now you are always being tested for your knowledge, whether you have learned it or not. So similar is the case for what machine learning models also, that how much it has learned, how it is performing, something like that. So that's why we have evaluation matrices, and they also make sure these also kind of provide what, a kind of feedback to perform better for the machine learning models. Okay, so that we have already seen our last lecture. And as I mentioned in the initial part of the session, that in the last session we saw regression evaluation matrix. So regression was the problem when we are trying to predict a value 2.3, 5.6, 100,000, minus 89.7, something like this. But if I talk about the classification problem, we are doing what? We are simply categorizing our input data, categorizing or classifying our data, that okay, this input data belongs to this category or this class. This particular input data belongs to this particular category or class. Just for an example, I'll just tell you that. Okay, so you can see the brief agenda over here, that like not much is there, but there is an important part which I'll be considering, which I'll be covering. Okay, so if I just talk about yes, so accuracy is the first evaluation metric I'll be talking about, but still let's just learn what exactly happens in classification problem. So just for an example, let's suppose we are having, as I just mentioned earlier as well, that we are having kind of what, different classes. So let's suppose over here that I'm having dog and cat images present with me. Dog and cat images are there with me, dogs and cats. Okay, so these are the two types of images I'm having. And let's suppose I'm having nearly whatever, like it can be like, let's say 47, and let's suppose this is 54, something like this. The total need not be 100. So like these are the random numbers I have taken over here. Okay, so suppose these are the number of images I'm having. Okay, now on the basis of images, I would like to classify each of the image, whether it is of a dog or a cat. So it's a classification problem. Similarly, if I would like to classify that, okay, there would be some input data I will be having for a person's health, okay, then I would like to predict whether he has a cancer or not, because you will see that these kind of problem plays a major role in understanding, evaluation metrics. You'll realize in the next session. Okay, so again I will be classifying it a healthy or person having cancer, okay, something like this. Or what can be there, that okay, we have created a system, uh you know face based detection system, that only if you show your face, it will identify that whether you should be allowed to enter within the building or not. Face based detection system to allow entry into a building, let's suppose something like that. So again, for that kind of problem, there will be category, classifying that okay, whether it should be allowed or not allowed, something like this. So we are categorizing, we are classifying whether should be there or not, or person having a disease or not, images of dog or a cat, something like this. I hope you are getting this, the classification problem. Okay, so now what happens is, whatever problem I have told you over here, those are binary classification problem. These are just binary classification problem, and I will be dealing with binary only within these lectures. Binary classification problem, that means I have only two category or class to classify. Okay, that I will be categorizing or classifying input data within either of these two only. So there are no 3 classes, 4 classes, 5 classes. If I have more than 2, then we will say multi-class classification. Though binary is also, but we use multi-class classification for more than 2 classes. Okay, multi-class classification problem. Okay, I hope you're getting this, the simple stuff. So we have understood, okay, what exactly is going to be a classification problem and what exactly is binary classification when we are categorizing or classifying within 2 category. Important, simple. Okay, so what would be the, how will you be judging that, okay, if your machine learning model is classifying, okay, this is dog, this is cat, this is dog, this is cat. So what is the most important, first criteria you can think of? That is always accuracy. I guess you would agree with me on that. Let's quote some example and then we'll understand with the help of that. Suppose something like this is there. So we have a dog. Oh, okay, not like this, not like this. Suppose I have it, let's suppose, yeah. So class. So I'm going to write actual and predicted class. Okay, let's suppose something like this, because there will be some kind of prediction taking place and I will be having only 5 data points I will be writing, or let's suppose 7 is good. 4, 5, 6 and 7. Let's suppose actual class, I'm picking up this dog and cat classification. Okay, so let's suppose the first input data point was of dog, and then again dog, then cat, dog, cat and cat, something like this. So these were the actual classes. Okay, these were the actual images. We know that, okay, corresponding to first data point, the image is of a dog. For the second image, the image is again of a dog. Third is of cat. Fourth is of dog. Fifth dog. Sixth cat. Seventh cat. But when I'm giving it to machine learning model, and if it is predicting the class, for that, let's suppose it says that, okay, it's a dog, it's a dog, it's a dog, it's a cat, it's a dog, it's a cat, it's a cat. Let's suppose something like this was predicted. Let's suppose something like this was already predicted. Okay, so now you can see what are the correctly predicted classes. What are the correctly predicted classes? So this is correctly predicted, wrongly predicted, correct. Yes or no? So if you want to judge, okay, that how is my prediction over here? So the first criteria, the first metric you can think of is correct classification, correct predictions upon total predictions. Correct predictions upon total predictions. And that's what accuracy is. That's what accuracy is. So how you can write that? What is the formula for that? Very simple. I can simply write it as, see this over here. So accuracy is nothing but number of correct predictions for all the classes, because all the classes are considered all together. Okay, all the classes are considered all together, divided by total data points or total prediction, whatever, because the total prediction will be equal to the total data points we have considered. Okay, so we can say total prediction, and that's what our accuracy is. Okay, so you can simply see like over here it's 5 by 7, 5 by 7, and if you would like to find out in terms of percentage, you can just simply multiply it by this 100 and you'll get it. So it would be around 71% something. Okay, 71% accuracy would be there if we just follow this. Okay, so this is accuracy, very simple. I hope you have got this idea. Okay, now to be honest, accuracy is not a good evaluation criteria. The famous reason I would like to quote is, sometimes the cost associated with error is different from what we have over here. So let's suppose if a cat was dog, if cat was said to be a dog, what was the problem? Was there any big issue over here? No, it was just a classification problem. We did it. That's it. Was there a problem if I said, okay, dog to be a cat? Was there a big issue? No, it's just model is not predicting good. That's it. Okay. But what if I say that you are actually using a classifier on, on some health data, and you're predicting someone having a disease or not? In that case, the matter is of life and death. I hope you get this, that okay, if your machine or if your whatever type of tool or whatever diagnosis you are using, okay, and if that predicts that person is not having a disease but he has a disease, in that case it is very dangerous. It will be very harmful. That machine learning model or whatever diagnosis what should I say, tool is not good enough if it is doing that. Okay, there must be some kind of error we can associate, but it should not be like like 70%. That is not something we should be considering over there. Okay, because there is the cost associated with each type of error. So if there is not we are not considering about the cost associated with the error, or if there are imbalanced data, then also there is an issue. What exactly is the issue? See, if I say there were, let's suppose I make 6 dogs. I make 6 dogs over here. I just modify it. I will just modify it. So if I simply say this was also a dog and this was also a dog, and instead of saying anything like cat, what if I say that all were dogs? If I simply say all were dogs, what will be happening then? What will be happening then? If I say all of those were be dog, of all the pictures were of dog, no major thing. You'll say that okay, my accuracy is like 6 by 7, which is like if you just multiply by 100, you'll get to know like it's above 80%. Above 80% accuracy you're getting. So no major issue. But still we are not able to consider for the minority class. For an example, this was a simple example. If I say if I'm having 10,000 total images, 10,000 total images, out of that 9,856, suppose, so these are of dogs only, and rest of them are of cats, and if my predictor simply tells that while predicting that every image is of a dog, so you will say the accuracy would be nearly 98%, 98.56% directly. Okay, because if it says that all the images are of dogs, so you can just get to know that okay, 9856 will be the correct prediction upon total. So 98.56 is the accuracy. It's a good thing, but there is a problem because it is not recognizing the minor class at all. That is already at a disadvantage because it is having less number of instances. And then again, if you are not even classifying any one of from those, then we have an issue over there. Okay, so when we have imbalanced data, when we have different cost associated with each type of error, as I mentioned, if a dog is said to be a cat or a cat is said to be a dog, if there is a cost associated with these kind of error, we need some better evaluation metric. Accuracy is not a good metric. Okay, if I say that diagnosis tool has an accuracy of this thing, no, we can't rely on that. We need some different evaluation metric, which we will be discussing in detail as we follow for the classification evaluation matrix. So I hope you have got the idea. What is accuracy? How do we calculate that? Why it is not a good evaluation criteria when we have imbalanced data set. Imbalanced data set means when I'm having a majority class which is having more than 90 or 80% of the instances. For an example, if I'm having 80% of the dogs images only and 20% only of cats. So if my classifier simply says that everything is a dog, then it is again coming out to be 80% of accuracy. But that's not good, no, because it is not even recognizing any of the cat. That's an issue over there. Okay, so we'll see that what are the good evaluation metrics. So I hope for accuracy the point is clear. Now we will move further. So the next is confusion metric. Now confusion matrix is not exactly an evaluation metric, but it is a kind of tool which helps us in finding out, which helps us in calculating different metrics which can be used. And I'll tell you that how accuracy is calculated with the help of confusion metrics. Okay, we'll see that. So the important problem over here is, as I have mentioned, that we are discussing about binary classification only. So it would be like that one class we will consider as positive class, the other class we will consider as negative class. That is up to us. Okay, we can consider any class to be positive and other class to be negative. That is completely up to us. Okay, that depends on problem to problem context. Okay, so let's suppose for dog I am saying the class is positive, and for negative I am saying that okay, it is of cat. So cat class is negative class and dog class is positive class. Let's suppose that. Okay, the category, because I won't be talking about dog or cat now, I will be talking about positive class or negative class, positive class data point or negative class data point. I hope you are getting that. Okay, so confusion metric is nothing but an evaluation tool which helps us in calculating, which helps us, you can just simply, like, it's very simple, which helps us in calculating different metrics by summarizing output of classifier. Basically it summarizes the output, that what the output. Okay, it summarizes all that. So as I just mentioned, let's take the previous example only. So where we had 7 total data points, out of that 5 were of dogs, if you remember. Not 5, I guess, like what this. So yeah, if I just have a look at this, so I guess there was a cat present over here. Over here also it was cat. So 1, 2, 3. So 3 were cats and 4 were dogs. Okay, so I'll just erase it. 4 and 3 was the total count for each of the class, positive and negative. So oh, sorry, yeah, so 4 of dogs, that means positive class I'm talking about, and 3 of cats, which is negative class I'm talking about. Okay, let's suppose something like this. And you remember the predictions. We'll just go through that. So let's see how we create confusion metrics. Okay, and for that you have to understand this thing what I'm writing. Okay, and this also you'll find that okay, different people write in a different way. Actual class, predicted class, because it's a matrix, so definitely there will be some rows and column. Predicted class. So over here I will be writing plus, over here I will be writing minus, over here I will be writing plus, over here I will be writing minus. Okay, so one more thing, I say positive, sorry, I say true, you just learn it properly, because this may be confusing. Okay, as the name suggests, confusion metric, it may be confusing for number of people. Okay, so just remember, when we say what true, it means I'm talking about correct prediction. The prediction was correct prediction. If I say false, then I'm saying the prediction was false or incorrect prediction. Incorrect prediction. You just need to remember this thing. That's it. This thing, positive class, negative class. That's it. Then you'll be able to understand this carefully. Okay. Now let's see. So if I just, calculate from the previous one. So if you remember, this was cat. Okay. This was also cat. So if I just talk about what? Our positive class. Okay. Actual one is also positive and predicted was also positive. That means if it was dog and predicted was also dog. What was the total count? Let's see. Dog predicted dog predicted dog predicted wrong, dog predicted dog. So there are 3 instances you can see over here. When dog was there and it was predicted to be dog only. You can see this. 3 is the total instance. Okay. So I'll write 3 over here. Okay. 3 over here. Now, what is for this? What will come over here? When actual was positive class, which is dog, but it was predicted to be negative. That means cat. So dog predicted cat. What is that? Dog predicted cat. Dog predicted cat. I guess only this was the instance. Only this was. So this cat was the initial because I modified this earlier. Okay. So dog called to be cat in the prediction. How many cases are there? Only one case. Dog to be cat, dog to be cat. Yeah, only this one was there. Dog to be cat. Okay. So one instance for that. Okay. Now let's see. Negative class predicted positive. That means cat class was predicted to be a dog. Cat class predicted to be a dog. Cat predicted to be a dog. So this was only one instance of this. What else do we have? Negative class predicted negative class. So cat predicted to be cat. So yeah, this was fine. This was fine. 2. So you can see this is the confusion matrix. Now if I just tell you what exactly these are called, let me just, fill those details as well. This part is called true positive. Now see, because the prediction was true, you can see this. On which of the portion I have, correct prediction? Over here I have the correct prediction. Over here I have the correct prediction. Yes or no? Because positive class predicted positive. Negative class was predicted negative. Negative class actually within this and predicted negative. So these two are true predictions. So true will be coming over here. Okay. And now what exactly was the class I predicted? Okay. What exactly was the class which was predicted? So now see over here. This was predicted to be positive. So positive. This was predicted to be negative. So it is negative. True negative. Now what about this? So this was false prediction. Because positive class was predicted to be negative. So it is a false prediction. Now what was predicted? A negative class. So false negative. So whenever we write, that is according to the second letter. Second letter is for prediction, that what was predicted, and first letter is for correct or incorrect. So if it is correct, it is true. If it is incorrect, then it is false. Now prediction class, and second letter is for prediction class, but whether it was predicted to be a positive class or negative class. So what will be over here? It will be false positive. Why so? Because the prediction is wrong, so false. Now negative class was predicted to be positive, so prediction was positive. Wrong prediction, positive class, false positive. I hope this idea is clear. So I will write each of these now again. Okay, just to understand. So these are important. What is true? What does true refer over here? True means correct prediction. What does false refer over here? Incorrect prediction. What was positive and negative? Positive and negative were the classes which we were referring to. Now if I talk about TP, FP, FN, TN, what are these? So second letter refers to the prediction class. Basically what is predicted? This is prediction. Okay, and this is the actual class which was there. And first letter refers to whether the prediction was correct or not. So true or false. Oh, okay. I hope you got this. Okay. So what sometimes, in different books, what you can find is, or different blogs, YouTube videos, what you can find is this predicted class is written over here and actual class is written over here. So what will change in that case? Only this thing will change because it's a transpose of this kind of matrix. Because true positive and true negative will remain over here only. Even if you change predicted class over here and actual class right over here, this will remain same. True positive and true negative. Only this thing will change. And that you can again understand. If I just write predicted class vertically and horizontally actual class, you'll see that over here what you'll be writing would be false positive and over here what you'll be writing is false negative. You can just try that on your own. Okay, that's very simple. So just to summarize again, what is true positive, what is true positive, what is true negative, what is false positive, and what is false negative. Let me write. So true positive means correctly predicted as correctly predicted as positive class, as positive class. So I'm just writing positive. What does true negative means? Correctly predicted as negative class. False positive means incorrectly predicted as incorrectly predicted as positive class. And what is false negative? Incorrectly predicted as negative class. Because the prediction is wrong and the prediction was negative class. So that's false negative. I hope the idea is clear. You must revise this. You must go through this again and again. This must be clear. In fact, I can recall it that, okay, how many times I need to go through, because I used to be get confused that, okay, what is the formula for precision? What is formula for recall? And what is actual? Should I write vertically or horizontally? So this used to be the confusion. But now, because this way nobody explained us, okay, that is like we have just learned through book and all that. So right now I have focused more on explaining that, okay, what exactly is true over here, what is exactly false, what is positive, what is negative. I hope you are getting it. So like for this much of effort, I guess एक like तो बनता है. So do like and subscribe to the channel if you haven't yet. Okay, so I hope this idea is clear that what exactly is true positive, false negative, false positive, true negative. Now if I just ask you what is the accuracy, and you can see the total data points were 7 and I have 7 total, what should I say, 7 7 output has been captured. 7 outputs were captured. So for correct prediction 3 and 2, 3 for positive class, 2 for negative class, and like for the wrong predictions as well, some like for false negative separately, 1 for false positive. So I hope you can get that confusion matrix calculate or basically captures each of the output for the classification. Okay, that what all cases can be there for correct prediction, wrong prediction, it captures everything. Now depending upon which this is also an error. Yes, this was wrong prediction. This is also an error, wrong prediction. Now depending upon which error is more important to me, which error should be minimized, like if I have some weightage associated, I use a different evaluation matrix for that. Okay, that is the thing which we will be discussing in the next class, precision and recall. Okay, and F1 score as well. So if I just talk about the accuracy from over here, what is your accuracy? It is nothing but true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. I hope this idea is clear. Okay, very simple over here. Okay, so this is quite simple over here, how accuracy is being calculated with the help of confusion matrix. Okay, very simple. So now the point is, confusion matrix is not something which is being like directly used for the evaluating. It is basically representing me that for each of the class what exactly kind of output I'm getting, and then for that particular for after getting that output, we will be predicting further, okay, that okay, what should be the evaluation metric I should be using depending upon the type of problem, which error is more important to me, which we will be discussing as mentioned for the cancer detection, for the face detection based entry to some building, something like that, authorization. So we'll see in the next class that how precision is more important, how recall is more important, when precision to be used, when recall to be used, when F1 score to be used, and how accuracy is not a good measure over there. Okay, that we have already learned over here. So with confusion matrix also, we can find out the accuracy as correct prediction upon total prediction. Correct were true positive, true negative, divide by true positive, true negative, false negative, something like this. Okay. So I hope you have got this. I guess you can expect a question based on confusion matrix. Okay. Because this is very important evaluation metric. From confusion metric, you get to know accuracy, precision, recall, F1 score. These are very important. So some question based on it that, okay, you may be asked that what exactly is the true negative cases, what exactly is the false positive cases, because if you don't understand these terms properly, then in that case you won't be able to identify the count for each of these. Okay, as we have understood with the help of this example. Okay, so I hope it is clear. So now we will end this session over here only, because I cannot complicate it further, because we need a separate session to understand more of it, which is precision recall. Okay. So we'll be devoting enough of time. We have ROC and AUC as well, which we'll be discussing, because in classification, there is a number of evaluation metrics which we can discuss. Okay. So that was it, guys. So you can just, join our WhatsApp channel for the regular updates, or if you have any doubt, corresponding to the lecture, or any exam related doubt, any question you're having, you can post in the comment section as well. Apart from that, you can join our Telegram group as well, and you can follow us on Instagram as well by scanning this QR code. And one more important thing, don't forget to attend this session, which is going to be tomorrow at 8:30 in the evening. Okay, so till then, take care, guys. Bye bye. Thank you.